same thing. I will share my answer with you. So if you got the right answer, you can turn it for a second and work on the front page instead. The speed or the magnitude of the resultant vector should have been 566.366 miles per hour. And the angle that it makes is negative 56.991 degrees. Now you can add 360 to that if you want to get a positive angle. I don't know why you would, because it's an extra step. But you may not add 180 to that. That would be going the opposite way. Okay, so if you did not get those two answers, then you need to follow along and see where you went different and highlight what you need to study. All right, bearing 1, 550 miles per hour at a bearing of 140. So, bearing, if I'm not given specific directions, I'm going to assume that's from the north line clockwise. So from here to here, this would be a bearing of 90. This would be a bearing of 180. So 140, close to the middle there. Let's head it this way. And its magnitude is 550 miles per hour. So from here to here is 140. All right. You gotta know how a bearing looks for you to get that angle. So there's vector 1. Vector 2, I'm going to put at the end of vector 1 because it helps me see the resultant vector. It is wind, and it goes south 40 degrees towards west. So from the south line, it turns 40 degrees towards west. That would be the direction of the wind, and it's only 70 knots. So I tried to make this much smaller than this. I want it to be fairly to scale. So now I can visualize. I started here, and I ended here. Alright, and to come up with these numbers, to figure out the actual speed of your plane, I need to break each one of these vectors down into components. So how much is the airplane going east, and how much is the airplane going south? That's not the airplane. That is this one. Usually use these colors to help you see. And this one, yeah. So there's my airplane. So 550 miles per hour would be the magnitude. Find out by the cosine of the angle I plus the sine of the same angle J. That would give me trig form. I'm going to distribute the 550. And I'm going to be extra careful about the angles because if nothing else, I've warned you that's where the most mistakes are. You may not put in 140 degrees there. 140 degrees is in quadrant 2, and that's telling your calculator, telling this trig, you're going left and up. The airplane is definitely not going left and up. When you plug in the angle into sine, cosine, tangent, whatever, it better be in standard position. So from the positive x-axis, how much did you have to turn counterclockwise? Well, I know this is 140, and this much of it's 90, so this much of it's 50. So that angle was 90 plus 90 plus 90 would be 270, plus 50 is 320. Alright, so I'm going to try that again. 270 plus a lot of multiplication, but add 4. So be careful with the arithmetic piece too. Again, if you just throw in 140 because you see 140, the rest of your work won't come out right. You would be going left some and up some, and that's not what you want. You want it to be at 310 degrees from standard position, positive x-axis. Alright, and then my wind is dragging it west and south. So how much west and south is going to be calculated with its component form. So I'm not going to write out the trig form this time. I'm going to just distribute 70 cosine of some angle and 70 sine of the same angle, and same thing. Plug in 40 if you want, but don't plug in 40 if you want the right answer. 40 degrees would be you telling it from quadrant 1, which would be right and left. This is going left and down. I'm sending it on the wrong way. You can't ask your calculator to give you the right answer if you don't have the right information. So again, from positive x-axis, counterclockwise, the 90 plus 90 plus, well, if this is 40, then this has to be 50. So 90 plus 90 plus 50 would be 230. So you have to do a little bit of work on those figures. But now the calculator is going to do most of the rest of it, but you need to see how these pieces fit together. I'm going to consider both of these at the same time, combine them by adding. I'm going to add these together. I'm going to store them in my calculator as x. I'm going to add these together. I'm going to store them as y. That is going to represent the component form of my resultant vector. How far left or right is it going? How far up or down is it going? And since those are two sides of the right triangle, the hypotenuse length, which represents the magnitude, which represents the speed of the plane, can be found with the Pythagorean theorem. So you type that in, that's where that number comes from. The angle given opposite and adjacent will be inverse tangent y over x. And in this case, your calculator is going to say negative 56.991. And I can see my resultant vector is down here in quadrant 4. Negative 56.991 makes sense. Adding 180 will send it the opposite way. I don't want to add 180 this time. So that's what that is. We need to see how the questions are all finishing the same. All that's changing is the magnitude and the angle. So some of this is adjusting, but the process to each one is not just saying that was right. Okay, so for those of you that followed along with me on number 8, because you had missed it the first time, do you need to ask any questions or clarification?